Good afternoon, ladies and gentlemen. So, one more lesson that I wanted to do for you today. This one is going to kind of conclude our unit on functions, and it is lesson 8-4. We're comparing two linear functions or two linear equations. How can I identify the similarities and differences in two different linear functions? Now, if you look at them as graphs, okay, you're going to see that one is gentler, one is steeper. They cross the y-intercept at different points. Okay, and when that happens, we have an intersection. Okay, but guess what? You don't always have to graph it. You're not always going to have graph paper. So let's look at what our options might be. Okay, and I'm grabbing a couple more colors to help us out. Okay, so on this first one, the equation, and you can see it really clearly in my printout, but in your photocopies it might be a little rougher. Y equals negative 1/4 x plus 2. Okay, so that's this line right here. And I'll just kind of underline it in the same highlighter color. Okay. Now, if you notice, here's your slope, negative 1/4. Anytime your slope is a fraction, it's going to be gentle. Okay. And if it's negative, okay, it should be going downhill, which is a challenge here because it's not. It means somebody graphed wrong. But it does intersect at the point 2. Okay. And so what I'm going to say is we're going to rewrite this. The book was wrong. And we're going to call this a positive 1/4 slope and just say they had a typo. Okay. So you have a slope of 1/4. For every 1 it rises, it goes over 4. Gentle increase. Okay. The other one, the equation y equals x minus 1. Now, that is this steeper line. Still not real steep, just kind of a steady line. Your slope, once again, is here. And remember, it's an implied 1x. And your y-intercept or initial value, okay, and that's this one right here. Okay, so I highlighted the two different lines. The result of having different slopes, different rates of change, and different initial values, okay, the result of that is going to be that we have 1 point of intersection. They are going to run into each other at one point. Okay. Now let's look at this next option. Okay. In this next one, we again have two different lines, two different equations. Okay, so we have y equals negative 1/2 x minus 1. and y equals x, a positive x, minus 1. So this first one is going down. It's a negative slope. It's going down. The second one is going up. Okay, it is a positive slope. It's a little invisible 1 right here. But what happens when you have different rates of change and the same initial value is that you intersect at the y-axis. They start at the same point and then go very different directions. Okay. Now, the last one I want to look at, okay, again gives us two equations. Y equals negative 1/2 x plus 2, and y equals negative 1/2 x minus 1. On this one, we have the same slope. Same slope. Different initial values. Your result there, parallel lines. They're running side by side. They're doing the exact same thing, but they started in different spots. So they're going to be parallel. A good example of this one is ages. I'm 2 years older than my sister. The years keep going by, we keep getting older, but I'm always 2 years older than my sister because the time is passing at the same rate, the same slope. So hopefully this helps you make some comparisons just using the equations instead of having to necessarily see a graph of every single line. Can't wait to see you in class. Thank you all so much.